Alrighty. Good evening, everyone. Thanks for stopping by on the day after April Fool's, where we're going to turn out that we're getting pranked by XML year round, unfortunately. We'll be getting started in just a minute. Let's get going here. So, some of the slides for today's talk are going to be paired with example code. And you can grab all that code from the tools website, which is tools.rps.ec. You can also find links to the slides, including this slide deck, on the website. And you'll see a little thing in the corner that says, which file we're looking at the moment. Each one of them, when you run it, will show you whatever's currently being talked about. In this case, it says hello. In other ones, it launches nuclear missiles. We'll get to that. And just in case you don't have the requirements for, you can just use pip install requirements to grab the library you need. But totally optional, and we'll be walking through them live on stream as well. So, we've all heard of XML. I think everyone, it's one of those recognizable file types out there, but you might not know what it actually is. Is it a thing you make documents out of? Is it an enterprise-grade, vertically integrated, turnkey, full-stack solution innovative startups? Is it verbose claptrap? I don't know. I think it's a bit of all the above here, but let's get down to the brass tacks here. So XML is I should say extensible markup language, not extensive. And it's a markup language. It provides ways to annotate bits of text to actually, to give more meaning to it. So, for example, it'll let you, say, okay, so this bit, went backwards. That was weird. My slides malfunctioned. Anyway, sorry about that. So it allows you to, say, okay, this thing is a link, or this thing is a list of things. Like if you're familiar with HTML, that's a markup language, and we use the, you say, okay, here's a list of things, bullet points. So here's some bold text, or Markdown, for example, is the name kind of implies a markup language, and that's a very simple language that lets you do stuff like say, okay, make this text bold. So this makes documents that are both human and machine readable. And a lot of people kind of hate XML. And after preparing these slides, I can't entirely disagree. A lot of the kind of hacker types to test it, because it's all corpo, it's extremely verbose, it's stuffy. It's used by people who make Java SOAP applications, which I still don't really understand what the point is, but I know I hate it. But let's not blindly hate XML. Let's hate it for good reasons. So, kind of first question we ask is why? Why is XML? Well, as the name implies, XML is extensible. So you can use it to describe and build very complicated structures, very complicated data types. If you're familiar with things like, JSON, for example, JSON does let you store structured data, but it's not a thing that can describe like a schema. It's not a thing that can, give very complicated attributes and little bits and relationships between things that are enforced by the language. Now, JSON is just a lightweight way to store objects. Why is my slides going backwards? I'm having some problems right now. Apologies. Actually, I'm going to check something real quick. We'll pause for 1 second. Sorry about that. Okay. Hopefully that doesn't continue. Not sure what's going on there. Anyway, so XML at its core is pretty simple. A document, the complexity arises as we attach more stuff to it. So a document is made up of tags. Each tag is enclosed in brackets, those little angle brackets, and they can be a start tag, an end tag, or an empty element tag. And these tags can contain attributes. So it could be, some tag with some attribute whose value is some value. And you can have comments. It's just like you say, okay, this stuff isn't actually data, just ignore it. It's for humans only. Now, this looks really similar to HTML, and there is indeed a lot of overlap. If you can read HTML, you can read XML. But HTML is not actually XML. There was XHTML, but no one liked it, and we don't use it anymore, which is a little sad. So unlike HTML, XML does have some actual standards. You might know that with HTML, you can kind of just do whatever you want. You can play fast and loose, and it just kind of works. You have tags, you don't close, you don't have a head, whatever. Mismatch tags, bogus usage of tags is tags with spaces and tabs in the middle of them. It doesn't matter. Browsers are desperate to make every single website work, so that means they have to be incredibly lax about what they accept. XML parsers, on the other hand, are absolutely draconian for the most part. If you have any mistakes, they just tell you no, and they give up. As we discover later, it's probably a good idea that they do this. So this brings us to chapter 1 of our XML saga, entitled A Billion Laughs. So, in XML, entities let us represent a piece of data. It's kind of like a variable, you could say. And you're probably familiar with some of them already. Okay. Interesting. It's just moving slides around on me. I hope that it's doing that. Well, we'll persevere anyway. Google Slides can't stop us. So, you're probably familiar with some of these things already, like the greater than, less than, and ampersand. Because if you're writing HTML, you can't just, type one of those, because that'll start acting like a tag. The solution, therefore, is to escape them. So in this case, we rewrite, the right bracket as amp gt semicolon, and that will then be replaced with the actual symbol. And this is exactly what XML entities do. They're just some tag starting with an ampersand, little name, semicolon, and that can then be replaced by something else. So XML will let us actually define new entities in the document itself. We do this in the document type definition, or the DTD for short. And you'll find this kind of incomprehensible looking thing at the top of every XML document. In this case, it's like doc type, it's the demonstration, and it has this entity called entity1, and its content is, this is entity1. So then in the body of the XML, we can use the entity, like this. We made up this tag here. This is not valid at all, but, we're not validating right now. We don't care. And we have this thing tag, and it contains entity1. So when we parse this, it actually turns into, this is entity1. And if we have a look over in our VM here, this is the tools, once this thing unfreezes, from the tools website, we grab the XML demos file, untarred that, and in here we just have some files to have a look at. So if we run one of these, like in this case, entity.py, it will show us both the raw file as well as the actual parsed file. And this is all using the LXML Python library, which is pretty nice to work with. So, as you can see here, we define this entity, and then this is the actual document, like the body. You notice that when we parse it, this kind of doc type bit didn't actually show up. That's because that's kind of, it's a preface, kind of a header almost. And so in this case, entity1 became, this is entity1. So, very straightforward, Nothing scary here. I'm not frightened yet. Now, entities can also contain other entities. This is where we start feeling that primal fear. So, for example, I could have entity 1, which is actually just entity 2, entity 2. And then entity 2 is like, oh, it's entity 2. And if we parse that, we get 2 copies of the entity. Again, very straightforward. Now, the troublemakers among you, which I hope is everyone in attendance, would probably immediately think, what can I do with this? Well, you can wind up producing what's kind of like an exponential blowup. Now, what if I define A to be 10 Bs, B to be 10 Cs, and C to be 10 Ds, and all the way down to Z? Well, we're going to get something like 10 to the 25 Zs if we type in A. And this is what is commonly known as the billion laughs attack. This is like baby's first XML problem. And you basically just make an entity that explodes into a colossal structure that takes a lot of time and effort to process. So this doesn't, let you, own the box stores or anything, but it does let you cause denial of service. So, this is an example here. I made a little. It's 1,000 laughs. So A expands to 10 Bs, B to 10 Cs, C to 10 Ds, and D to lol. And if I parse that, yeah, we get 1,000 laughs. Nothing too catastrophic. Now, one interesting thing here is that this kind of attack is, not really possible to prevent in general, but it is possible to kind of mitigate it. If we have a look at the XML parser file here, we'll see that I have this option here for LXML. And I'm sorry, I just left you on these slides. Let me bring you to the VM. There we go. As you can see, giant pile of lols. And if we pull open the file here, you'll notice I had to tell it explicitly, yeah, you can make huge entity trees. If I turn that off, then come back here, it gets upset. It calls it an entity reference loop, but it's really just an excessively sized tree. Most legitimate uses, don't really need a million things. And there's a question, what if you make a circular dependency? Well, let's find out, actually. I think this library will still get upset and just tell you no, but you might as well try. Please open the file. Thank you. Later. Go away. Let's make sure I am on the virtual machine. Yes. So let's just make A into, I don't know, to B. And let's make B into A. That sounds good. Let's get rid of these. Who needs those? Okay, yeah, it finds a loop. Now, I'm curious, what if we turn off the protection? Okay, it still gets upset. So yeah, some really old and rather terrible parsers will probably just immediately perish when they see that. But anything vaguely modern, should survive without trouble. So yeah, as I mentioned, a lot of things will kind of have some heuristic for like what's too much. I think this one has like a few dozen or a few hundred entities. Now, of course, you could imagine this might break your legitimate documents. And therefore, your boss tells you, oh, just turn it off, who cares? And so thus the detection is turned off. And now some obnoxious 12-year-old is bullying, laughing your entire website to death. And thus the cycle of life continues. So a lot mitigations against these kind of, these sort of denial of service attacks could be very fiddly. Now, there it goes again. XML parsing is decently complicated. And so just like parsing a modest amount of, like deeply nested XML, for example, can be resource intensive. Oh my goodness. What the slide's doing? I need to restart that if it keeps doing that. Sorry about that. Anyway, so it can be, quite resource intensive. And so you can, with some relatively trivial stuff like this beautiful, like 30,000 layers of A tags, cause a Stack Overflow and blow up Firefox. The OWASP cheat sheet had a whole bunch of nice examples of that in various, some of them a little bit antiquated, but some amusing things to look at. So that was chapter 1, just, entities. But now we get to the fun stuff here. External entities. So you can bring entities from outside of the document. And I'm going to restart Google Slides because that is happening too much now. Apologies. We will be back on it in just a minute. I don't know why technology. I think it's trying to stop me from talking about XML today. I can't blame it, but the show must go on. Just close out as many windows as possible, and maybe it's probably just up that they have like 20 copies of the Chrome open right now. Okay, let's see if we can be a little more stable this time. It's got to. Let's see. Bring us back. Where were we? Slide 29. We'll have to. There we go. Okay, hopefully that fixed it. If not, we'll just have to fight the computer. All right, so as I was saying, entities can actually reference data from outside of the XML document. And these are known as external entities, or XML external entities. You'll notice that they really love to use the X rather than the E. I think it's a little more extreme that way. But you'll see this as XXE. And oh god, why? Well, before we get to the oh god, why part, there are actually valid reasons to do this. For some definition of valid. So, for example, you might want to pull in a document type definition, a DTD, from some external source. Because the whole point of XML is you can make very well-defined schemas that actually validate your data and make sure it's well-formed. So you can pull your schema in from some external source. And, all as well. So just as a little example here, I invented this schema for cool documents. So the cool document schema is a... Oh, there it goes again. I wonder if Google Slides is having issues today. Oh, we'll persevere. So, cool document is an element. As you can see here, we just said, okay, bang element cool doc. And then we have a single child element called very cool. And the very cool element contains PC data. Now, PC data is just parsed character data. So basically text that is not more XML. It's just text, They couldn't just call it text for some reason. So this is a valid cool doc. You see we have a cool doc entity with a very cool element in here that contains some text. And to actually reference the schema, we have to put something into our doc type. We say, rather than just putting the definition in, because we could have just typed this stuff right into the doc type. Instead, we actually say, okay, well, go to this place. We go to system and then some path. This could be like a file path or a URL, which should be setting up alarm bells in your head. So, parsers can then reject invalid documents. And if you try running external DTT malformed, you'll see that it throws an exception because we have this uncool element here. The schema didn't say we can have that. It said we can have very cool, and that's all it said we can have. So these schemas are very aggressive. They're not just, oh, you have to have these things. It's you can't have anything but these things. So it's, like database schema, not just NoSQL schema, So notice that we use that system keyword, a little magic word there, to load that DTD file. So it just fetches some external resource. There's also a public keyword that's very similar, except it's you can have both a URL and some identifier, which is useful for commonly used things. You might have them stored somewhere else. Now, in some situations, attackers can influence the DTD. And that means attackers can do something like this. So let's just go over to our VM here. And we're going to go look at chapter 2. So we're going to run... Actually, let's have a look at first at file read.xml. So this just contains a doc type test, and it has a single entity called XXE. Very, very imaginative. And it uses system to pull in flag. and the document then renders with the XXE element in it. So if we render this document, we parse it, it will go from having entity here to having the contents of the file. If you look at file, there we go. So that means that an attacker who can control the DTD, which can happen if you're accepting just arbitrary XML from them, will be able to just kind of pull files out. Now, they don't necessarily just see the file. A lot of the times, this stuff is blind. Like the server parses it and then errors out and dies. But if maybe there's an error, but then you helpfully have an error message to help your user know what went wrong. Well, that can mean that suddenly it's possible to what did I say? It's possible to actually get that data out. Maybe you'll be looking up a product ID and then it'll just tell you, oh, invalid ID, and then the contents of Etsy password. Now, even if it doesn't, we have options, because you remember I said it can load it from a file path or a URL. Well, you'll remember SSRF. We talked about this a few weeks ago. Server-side request forgery. It's whenever you trick a web server into making a request that probably wasn't supposed to happen. So for example, if a website allows you to, load a file, saying you can just give it a URL and it just runs with it, you can make it access whatever resource you want. And this can lead to messing with stuff in secure, in intranets, and generally sneaking further into a network. So as a little example here, I have a two-part demonstration. So first, we're going to need two windows for this. It's getting crazy in here. Put that on the left side. And let's get ourselves a new terminal. Wait, can I have a new terminal, please? I'll just use Tmux. I haven't used this in a while. Okay, so on one side, we're going to run this little web server here. It's going to sit there. And if anyone accesses it, it will launch the nuclear missiles. Have a nice day. We've ended the world. So, obviously, that should not be. Ah, yes. Good catch. Thank you. RTX voice crashed. That's unfortunate. I will. Okay, let's cover that again here. We are having all kinds of technical issues tonight. I think it's just the XML is too cursed. So just to recap there. So we have a web server here that when you curl it or whenever you access it, it will launch the missiles. There we go. And so this is not accessible to the internet. Suppose it's only accessible, locally. Well, we need a way to cause SSRF to make that happen. And thanks to this XML file here, whose DTD has an entity that will hit a URL, we can just render that entity when the document is parsed and cause it to go off. There we go. And the response even winds up in the rendered document. And I was just showing there at the end there that by default, LXML does not go over the network. But, depending on your implementation or your configuration, you might be able to hit the network. So you can wind up getting SSRF entirely from parsing untrusted XML, which is amazing. Okay, let's hope that technology continues working until the end of the stream now. Fingers crossed. So one tragic thing is that you can only get. You cannot post, you can't head, you can't put, delete, that patch, that kind of thing. And that's probably kind of a good idea because I don't think that parsing XML should be a state changing operation. Although one might assume that launching the nuclear missiles is indeed state changing. That's an exercise left to the reader. Now, we can put these together, and things are get a little bit scary here. So we'll walk through this step by step. So if you look at srf2.xml, you'll find a little more complicated stuff. One thing you might notice is that in this document, there is no actual sign of an entity. There's no entity here. That's because it's up here and has a percent sign. We'll get to that in a sec. But for now, I'll just say, okay, so we made this entity, and it just, it goes system, srf2, it pulls it from a file, and then, it'll just evaluate it. So this declares an entity that references another file. And the percent sign means it's a parameter entry. So basically, if it doesn't have a percent sign, it's an entity for the document itself. But if it has a percent sign, it's meant to be used in the DTD itself. And so this is where you get some real crazy, not kind of metaprogramming almost. I mean, it's necessary for these more complicated XML schemas where we want to avoid, repeating ourselves constantly. And this allows us to, build up complicated schemas, or it allows us to launch the nukes. So this is a real weird looking bit here. You see that we have like escaped percent sign. We have like, oh, I don't like it. Let's go one line at a time here. So the first line declares another entity called path, and this is also, for the DTD, it's a parameter. And it will run system and read this secret path.txt file. So this means that this entity, path, will be replaced by the contents of secret path.txt. The next line is the doozy. So it declares one called send. And send itself will produce a definition of an entity. And that entity is called launch nukes. And it will invoke system with a URL and then path at the end. So when we actually render send, we wind up rendering another entity definition, and that will then go out and hit localhost. So let's have a look at that in action. Where'd you go? There you are. And let's get rid of this. Actually, I do need two windows again. And let's split you in half. So over here, we're going to run betterserver.py. It's more advanced. It can't be hacked very easily. No missiles here. The missiles have not been launched today. Everything is safe. Now, if we could just get this secret path.txt file and read this long, good old nuclear missile endpoint, URL fragment, we'd be able to launch the missiles. Fortunately, we can't do that because we couldn't possibly and imagine this thing doesn't let us exfiltrate data even if you think about it, if we can just read the file, but we can't send it to ourselves, we can't read that. So what are we going to do? Well, what we can do is exactly what we showed there. So we actually have kind of a two-part process here. First, we read that path in, and then we construct an entity that actually will make a request to that path. And it has to be that kind of two-step process because we first have to actually get that data in, and then we have to use it. And this is where that kind of crazy XML really kind of takes off because you can have these these entities that produce other entities, and it's all kind of self-modifying and mildly frightening. It's basically templates, and it can lead to, if we just run this little program here, it leads to two things. One, the missiles launch, and two, LXML blows up. Because at the end of it, I think it tries to parse the response as an entity, as a DTD entry, and it fails. So if we actually do it again when the web server is broken, it turned off, it's fine. And you'll notice we just get the usual document. So yeah, bit of a Rube Goldberg machine there, and that's definitely a little more crazy stuff happening. It's More complicated, but at the same time, more powerful and a little more fun too. For some definition of fun. So there's some further reading on the Portswigger website. They do Burp Suite and stuff, and they have some really nice little labs and other things to look at. Obviously, you cannot see the link here. If you go to the tools website and visit the slides there, you'll be able to click the link. Otherwise, just Google Portswigger XXE. There you go. Okay, this brings us to Chapter 3, A Tale of Four Parsers. I don't know if you've ever heard of Psychic Paper before. It's this handy little gadget from the Doctor Who series. Whenever it's presented to you, it shows whatever you want it to say. So if you're expecting a passport, it's a passport. If you're expecting a shopping list, it's a shopping list. That wasn't Xing rare. And so fortunately, computers aren't vulnerable to this kind of thing. They don't see what they want to see. They see exactly what they're supposed to see. Right? Right? So I'm not going to go into full depth on this. There's a great blog post to read if you want all the nitty-gritty details about exactly why this went wrong. But we're just going to look at this little story that teaches us why parsing XML is painful and how it can go horribly wrong in funny ways. So, two different parsers should agree on what a well-formed document means. Because if they didn't, then one of them is clearly just totally wrong. You have to parse correct documents correctly. But when you have slightly malformed documents and you don't just immediately bail out when you see something that's malformed, you can wind up with two disagreeing viewpoints on the same document. And this is exactly the same problem we've seen in many other forms. When you're two different things decode escaped HTML differently, or when your WAF cares about capitalization, but your browser doesn't. All these different this has come up so many times before, and there's just another instance of that. So Siguza, I hope I pronounced that, or was it Sigzua? I think I misspelled it. Anyway, they discovered an iOS sandbox escape. Which is a bit of a tasty thing, a bit of a fun thing to find. This got fixed back in 13.5 beta 3, rather unceremoniously. So, I presume that most of us aren't super familiar with iOS, so the real quick rundown is that every app comes with a manifest, which is an XML document that describes, what it is, who made it, when it was published, all that stuff, and what the app is allowed to do. So applications get entitlements, and these entitlements let them do things. A very interesting entitlement being the no sandbox one, which means that your app is not sandboxed at all. Now, you can't just put whatever you want into your entitlements list because, it has to be signed by Apple, and Apple's not going to just say, yeah, go ahead here. You can just have whatever you want. So iOS used 4 different XML parsers to read this data, which is pretty impressive. And so it wound up with this interesting situation where in one place it would check that you didn't have bogus entitlements you shouldn't be allowed to have. And in a different place, it actually used those to control what the app does. And these are 2 different parsers. So a while back we mentioned comments. Left bracket bang dash dash to open, double dash right bracket to close. That's simple. What could possibly go wrong here? Well, so a parser should see those 4 symbols, read all 4 of them, and then skip ahead forward to continue parsing the document. Unfortunately, one of the 2 parsers didn't. So if we sent some malformed XML, what's going on here? These are some weird comments, especially this one here. Well, we can wind up with problems. So one parser sees this whole thing here, and it only skips one of the dashes. So it then parses. So normally this wouldn't really matter because we've entered a comment. We don't really care what the comment is, and this itself should not be a closing comment. This opens a comment, but it should not close it. But it only skipped ahead 1 dash. And so that means the next 3 characters it saw was dash dash bracket. The comment is now closed. A separate parser would see the first 2 bits. It would see this and it would skip all the way ahead to here. And then, after that, it sees single dash, arrow, everything's fine. We didn't close the comment. So we have this interesting situation now where the 2 parsers think they're in different states. One thinks they're in a comment, one doesn't. And they run into this thing. So this is also a weird symbol. Like, no, I don't like it. The first parser thinks it's a comment, so it runs in the dashes and the bracket and closes the comment. The other parser sees, oh, well, okay, here's a bracket, bang, dash, dash. So that's opening a comment. So they've switched places. So one parser sees one thing, and another parser sees a different thing. They have 2 totally different ideas of what's going on. So the validator sees nothing. It's like, oh, no entitlements. Everything's okay. Then the app is thrown out of its sandbox. It can access arbitrary processes. It can just do whatever it wants. Oh, no. And something like this happens. Parser A sees one thing because it closed its comments instantly. Parser B only sees this bit because it actually it closes its comment here. So, lol parsing, basically. Parsing is hard. It's difficult, painful. XML is hard, painful. So parsing XML, painful. Really painful. So yeah, that's just a fun little diversion. It's really stupidly simple 0-day, really dumb sandbox escape. And the solution, I believe, was to add a fit XML parser. So the more things change, the more they stay the same. So what have we learned here? Other than that, XML is pain. Well, XML is kind of terrifying. It's a very flexible, very powerful, self-describing language that you can use to create really complicated data. Like we didn't talk about like the meat of this, like namespaces and how you like these incredibly elaborate documents. So badly configured XML parsers can go haywire. This could be because they just totally misinterpret the XML, as Apple did, or if because an attacker has put some funny entities into the DTD. And a lot, unfortunately, XML is a decently popular way to send like messages between different microservices or components or mega services, whatever the Java people are doing these days. So attackers can send XML with really interesting, document type scripters. So these exploits can lead to denial of service, to file disclosure, SRF, all the above at once. But there's one thing that we didn't talk about today, and that's it. I don't like talking about this. This is just a little too cursed. But what if we get arbitrary code execution? So PHP has a lot of wrappers. Unsurprisingly, the topic has come to PHP. Drive stop. So PHP will let you do things like, access pipes, like PHP stood in, stood out, or, filter data so you can, like, say, read with, like, as uppercase example.com. Or if you have the optional module installed, you can run a process. This is extraordinarily cursed. So OWASP has a little example here. And as you'll see, we define XXE as expect : / ID. And if we then let's log into the website, and here's my username, it's XXE. And so when this thing gets parsed, it will say, okay, your password is, your password, and your username is the result of ID. So this is, again, extremely cursed. And I don't know if this ever actually happened before, because you find this on basically every little blog talking about XXE as this really weird corner case. I'm not entirely sure it's ever actually happened, but it is amazing. And so, yes, it is theoretically possible with the power of XML and PHP combined to get code execution directly from XML, without exploiting a parser bug, because obviously you can just do that if you have an overflow or something. So that just about wraps things up here. So if you want to read about XXE some more, again, Portswigger has some great resources. Just pop on the tools website and have a look there. you can read about XXE and Blind XXE. They also have some labs which you can use to kind of practice this stuff. So we're going to be hanging out in the RPSec Mumble right after the stream ends. If you are on the Slack, you could find the details there and hop on. If you're not on there, you can join us at rpsec.slack.com. You will need an RPA email address to join. If you're not a current student, but you still like to hang out, you can email contact@rpas.ec. I'll put that in the description after the stream ends. Just let us know. We might be able to get you added. But yeah, so feel free to stop by for a bit. We're kind of hoping to recreate the fun kind of post talk atmosphere we'd have at our in-person talks, just in the modern online environment. So if you want to stop by, if you have any questions, if you want to ask anything at the club, if you just want to know how to hack Facebook, I don't know, stop by and say hello. But yeah, thanks for coming, everyone, and hope to see you in the Mumble, and hope you have a nice evening.